This video is on angles of elevation and depression. Specifically talk about angles of depression. We still want to create right triangles and use SOHCAHTOA. So angle of depression is the angle between the horizontal and line of sight to an object while looking down. So we still want to have a right triangle. So if I draw in a basic right triangle, I want to be able to see that I am looking down, so you would think it's going to start up here. But it does say it's between the horizontal and the line of sight. So this line right here is not horizontal. This is a vertical. The line of sight is from looking down from the top down to an object on the ground. So this would be our line of sight, but I need a horizontal. So I could actually draw in a horizontal line from here and then use my from horizontal to my line of sight. This is where your theta is located. It is not located here. Not here. Your angle of depression is never located up in that corner because that's a vertical and your line of sight. We want the horizontal. Now, this line right here, the ground basically, is actually parallel to this horizontal up here. And if they're parallel, we actually have alternate interior angles. These angles right here are congruent to each other based from alternate interior angles. So this could also be your theta because this one is inside the triangle. That's why we want to know this one so that we can do SOHCAHTOA. We can do trig. This angle is outside the triangle. So angle of depression is technically outside the triangle. You could create a rectangle and it's just basically the same two triangles. They're same two triangles. That's why we're able to use this though, because they're parallel and we have alternate interior angles. So the angle of depression is between the horizontal and hypotenuse. And actually, that's the exact same thing as the angle of elevation. And since these are parallel lines and we can do alternate interior angles, this is the exact same angle as the angle of elevation. So we can actually say this is the same as angle of elevation. So even though it says angle of depression, you could put the angle of depression inside the angle of elevation because it's the exact same angle. So let's look at some examples. From the top of a lighthouse, an observer notices a boat and finds the angle of depression to be 12 degrees. If the boat is 900 feet from the bottom of the lighthouse, what is the height of the lighthouse? Okay, so we know we're going to have a lighthouse. So let's draw in that lighthouse. You don't have to actually draw it, but you can. So lighthouse, a little bit of a lighthouse, however you want to draw it. We know we have the water. So I'm going to draw the water in here. And we have a boat. So that we know the boat's in the water. So my poor little boat. I have a little person on the boat. Standing on top of the boat. I don't know. But there's also an observer notices the boat. So from the top of the lighthouse. So my observer, say, is up here. Can see the person. So they observe the boat. So we have a right triangle basically. So now let's label everything that we have. So it says from the top of a lighthouse, an observer notices a boat and finds the angle of depression to be 12 degrees. Again, depression is between the horizontal and hypotenuse. Well, the horizontal we have in here is the water and the hypotenuse. So that's the same thing as the angle of elevation. This is 12 degrees. The boat, here's our boat, is 900 feet from the bottom of the lighthouse. So from the two things, from the boat to the bottom of the lighthouse, that's where we put our 900. Boat to the bottom of the lighthouse. This is 900 feet. What is the height of the lighthouse? That's from bottom to top. This is our x. So using trig, we're going to highlight our hypotenuse and label what's in our triangle. our theta is at 12 degrees. The 900 is attached to theta but not highlighted. That's our adjacent. And our x is across the triangle, so that's our opposite. So this goes O and A, that's tangent. So we have tangent of 12 degrees is equal to our opposite is x, and our adjacent is 900. We're given the denominator, so we're going to multiply our 900 times our trig, tan of 12. That's going to give us our x. It's going to give us our height. So, as always, we make sure our calculator is in degree mode. It is. So now we can do 900 times tangent of 12 degrees. It's roughly 191 3/10 feet. So the height of the lighthouse is approximately 191 3/10 feet tall. Next example says the angle of depression of a car from a hot air balloon basket is 40 degrees. The balloon is directly over a water tower that is 5 kilometers from the car. Find the direct distance from the balloon to the car. So again, we're going to draw a picture. So we have a hot air balloon is going to be up in the air. So hot air balloon, I don't know, some type of balloon. We have a car, which is going to be on the ground. You do not have to actually draw an actual picture. But I just want to. So we have our car, but the car has to be on the ground. So because we know it's not just floating in midair. Then it said that it also says the balloon is directly over a water tower. So the balloon is directly over the water tower. So here's my water tower. Water. So if the balloon is directly over the water tower, that means that from the balloon all the way down, that will give us our vertical. That's why we have a right angle. There's our right angle. We still need to draw in our hypotenuse. So we can draw in our hypotenuse to the car. Now we can label with our numbers. So it says the angle of depression. And again, depression, it goes from the horizontal and the hypotenuse. The horizontal on this problem is the ground. The hypotenuse is the red. So horizontal hypotenuse, again, that's the angle of elevation. Same thing. Is 40 degrees. So we can put our 40 degrees down here. The balloon is directly over a water tower, the water tower, that is 5 kilometers from the car. So the water tower is 5 kilometers from the car. Water tower, car. So our 5 kilometers goes here. It says find the direct distance from the balloon to the car. So here's your balloon, here's your car. We put our X on the red. So now we can label everything for our trig. So highlight your hypotenuse. Our theta is our 40 degrees. The 5 kilometers is attached to that degree but not highlighted. That's our adjacent. Our x is on the highlight. That's automatically hypotenuse. So a into h is cosine. So we have cosine of 40 degrees is equal to your adjacent, which is 5 kilometers, over your hypotenuse, which is x. You are given your numerator. That means you divide. So we take our numerator and divide it by our trig. 5 divided by cosine of 40 will equal to x. So 5 divided by cosine of 40 degrees, close your parentheses. We get roughly 6.5. That's not 6.5 feet, that's 6.5 kilometers. So x is approximately 6.5 kilometers. Means the balloon is 6.5 kilometers away from the car, which is in fact bigger than how far it is from the car from the water tower. So that's good. That's bigger than the adjacent. Hypotenuse should always be largest. Number 7, this next one, says a pilot is required to approach a runway at an angle of descent depression measuring 20 degrees. If the altitude of the plane is 10,000 feet, what is the flight distance to the runway? So now we're going to have a plane. I'm going to get my sad little plane. Little windows, cockpit. And we see that it's approaching a runway. Well, our runway, we know, should be on the ground. So it's approaching the runway. Approaching the runway. So we know that's where it's going. We also need to create a right triangle, so we have that vertical. It says that the pilot is required to approach the runway at an angle of descent or depression measuring 20 degrees. We know that angle of depression is between the horizontal and hypotenuse, and we know that the angle of depression is the exact same thing as the angle of elevation. So I can put my angle, that 20 degrees, from the horizontal to the hypotenuse right here. This can be our 20 degrees because it's inside the triangle. Again, it never goes here. If the altitude of the plane, altitude means the height of the plane. So right now it's at 10,000 feet in the air. So the altitude is from the bottom, the ground, up to the plane. This is our 10,000 feet. So then it asks, what is the flight distance to the runway? So the plane is not going to go down. It's going to fly at a diagonal. So the flight distance to the runway, this is your runway right here. So from the plane to get to the runway, that's where we're looking for. This is where we put our X. So going into the trig, we highlight our hypotenuse, and we label the trig part. Theta is at that 20 degrees. The 10,000 is across the triangle, so that's our opposite. The X is on the highlight, that's our hypotenuse. O and H is sine. So sine of 20 degrees is equal to your opposite of 10,000 over your hypotenuse, which is X. Given the numerator, we divide. We take our 10,000 and divide it by our sine of 20 degrees. And that'll give us our X. So 10,000 divided by sine of 20 degrees, close parentheses. We have 29,238. So it will take a long time. It takes it a while to get to the runway. So X is approximately 29,238, and it would be 0 tenths. So 29,238 feet away from the runway. That's how much further it has to fly. This last example, it says after flying at an altitude of 9 kilometers, an airplane starts to descend when its ground distance from the landing field is 175 kilometers. What is the angle of depression from this portion of the flight? So again, we want to draw a right triangle. We basically just want to draw a right triangle. We know we have an airplane. The airplane's up here. After flying at an altitude of 9 kilometers, that altitude is always from the ground up. This is our 9 kilometers. An airplane starts to descend when its ground distance from the landing field. So here's our landing field because our plane is starting to go down. Here's the landing field. The ground distance is 175 kilometers. We put the 175 on the ground. What is the angle of depression for this portion of the flight? So again, angle of depression is the same as the angle of elevation. It's between the horizontal and hypotenuse. The horizontal is the ground. Our hypotenuse is here. This is our X. That's what we're looking for. So, going back to the trig, I'm going to highlight the hypotenuse. I'm going to label everything. Our theta is where we put our X, because that's our X degrees. Our 9 kilometers is through the triangle, so that's our opposite. Our 175 is attached to our theta, but not highlighted. That's our adjacent. So opposite and adjacent is tangent. So we have tangent of X is equal to our opposite is 9, our adjacent is 175. So because we're finding our theta, we're finding our degree, we do the tan inverse of our fraction, 9 over 175. And that'll give us our x. So we do second tan of 9 divided by 175, and we get approximately 2 9/10 degrees. 2 9/10 degrees. So x is approximately 2 9/10 degrees. And if you think about an airplane descending, it doesn't want to descend too quickly, so not too steep. It wants to descend at a nice small degree so it doesn't stall and so it doesn't crash. So a degree, a small degree like that will make sense for a plane descending.